Welcome to another video tutorial for Learning Music Theory with Logic, Max, and Finale, published by Routledge and written by Jeffrey Kidda. In this video tutorial, we'll discuss pitches and natural intervals, including the topics of pitch names, octave position, scale degrees and names, intervals starting with whole steps and half steps, accidentals, enharmonic spellings, a pitch generator device created with MaxMSP, intervals, inversions of intervals, harmonic and melodic intervals, simple and compound intervals, the qualities of intervals, and the sound of intervals, including the concept of consonant or dissonant intervals. We'll also see how we can use Logic's chord trigger to create intervals and Logic's MIDI transform to invert intervals. Similarly, we'll learn how to create intervals with Finale's transposition tool and to invert intervals with the canonic utilities. Pitches are named with letters A through G. Shown here is the music of a grand staff with the treble and bass clefs and 4 octaves of the C major scale, starting on C, and the pitches C, D, E, F, G, A, and B. Every major scale has 7 notes. The notes are named tonic, supertonic, median, subdominant, dominant, submedian, and leading tone. We'll use these names to describe chords as well. Below the grand staff is a piano roll editor from Logic. The first note in the treble clef and the last note in the bass clef is middle C, or C4. The treble clef note in measure 8 is C5. The 4 in C4 is an octave position, so every pitch has both a letter name and an octave position. Ledger lines are used to extend the pitches above and below the staff. We can see in measure 13 there are pitches above the treble clef, and the first 3 measures have pitches below the bass clef. Successive notes on the scale can either have a note in between them, such as the notes C and D. There's a note in between them that you can see on the piano roll editor. Or they can be right next to each other, as in the pitches E to F. With one note in between, the interval, or the distance between the notes, is called a whole step, and when they're right next to each other, it's called a half step. Every major scale has a pattern of whole steps and half steps, which goes like this: whole, whole, half, whole, 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 half. If we memorize this pattern, we can recreate the major scale on any pitch. Another look at scale degrees and names. We have the C major scale and the names for each one of the pitches. Above the staff, we have the numbers of the scale degrees. And in this case, the numbers have a little mark above them, which is called a caput. And when you see a number with a caput, it refers to scale degrees. To name all the pitches, including those pitches in between the whole steps of the C major scale, we use accidentals. With all the pitches, we can create the chromatic scale, which has 12 pitches. A flat symbol lowers the pitch a half step. A sharp symbol raises the pitch a half step. Any letter name can have either a flat or a sharp. To show that a pitch is neither sharp or flat, we use a natural sign. Double sharps and double flats are possible, but they're somewhat less common. We'll notice that in measure 3, the D has a natural sign before it. Enharmonic spellings. All pitches can be named in different forms. The different names for the same pitch are called enharmonic spellings. In the music to the right, we see that the C sharp is the same pitch as D flat. 5 enharmonic spelling pairs are shown in this music: C sharp and D flat, F sharp and G flat, D sharp and E flat, G sharp and A flat, and finally A sharp and B flat. To help us learn how to read pitches, we can use a Max MSP patcher called Pitch Generator. The Pitch Generator simply randomly displays pitches on the grand staff when you click the new note button. After identifying the pitch, press the click for note name to see the pitch name and the position on the keyboard. Intervals are the distance between two pitches. Intervals between the notes of a scale are called natural intervals or diatonic intervals. To the right, we see the natural intervals of the C major scale from the tonic note to each of the successive scale degrees. The interval of the half step is also called a semitone, and it can also be called a minor second. Each of these intervals shown has a specific number of semitones. A whole step is also called a major second. Intervals are named by quality and ordinal number. The qualities of these natural intervals are perfect, major, or minor. The ordinal number, or just number, relates to how many lines or spaces separate the notes. Unisons are on the same line or space. Seconds are one space or one line away from each other. Thirds are the distance of line, space, line, or space, line, space, and so forth. The ordinal numbers seen here are unisons, seconds, thirds, fourths, fifths, sixths, sevenths, and octaves. Notice that the octave has the same pitch name in both places. In the previous slide, we noticed that all the pairs of the intervals have the tonic in different octave positions. To the right, we see that the first measure has two pairs of pitches B and C, and then C and D, then C and A, then C and E, and finally C and F. Each of these is a different interval. The intervals for the first pair are a minor second and a major seventh. The C in the minor second interval is transposed down an octave in the major seventh interval. To transpose is to move a pitch or pitches up or down. Each of these pairs of intervals consists of inversions of one another. The minor second is an inversion of the major seventh, and vice versa. The major second is an inversion of the minor seventh, and so forth. Melodic and harmonic intervals. Harmonic intervals sound at the same time. Melodic intervals sound one after the other and can be ascending or descending. In the first measure, we have a harmonic perfect fifth and then a melodic perfect fifth. In the second measure, a harmonic major third, then a melodic major third. In the last measure, a harmonic minor sixth, then a melodic descending minor sixth. Simple versus compound intervals. Simple intervals are one octave or less. Compound intervals are more than one octave. These include ninths, tenths, elevenths, twelfths, etc. Compound intervals can be understood as a simple interval plus an octave, or more than one octave. A major tenth is equivalent to a major third plus an octave. Interval qualities. While the natural intervals of the major scale consist of perfect major and minor intervals, there are two other possible interval qualities that we need to be aware of at this point: diminished and augmented. The diagram here to the right shows how intervals change quality based on the number of semitones between the notes. We will consider the diminished and augmented intervals qualities later. Doubly augmented and doubly diminished intervals are also possible, but are very rare in actual music. The sound of intervals. Intervals have different sound qualities. Some intervals sound more restful, and these are known as consonant intervals. Some are more agitated sounding, and these are known as distant intervals. Generally, people might indicate when listening to the intervals that consonant intervals are more pleasant. But distant intervals play a vital role in music. We can use Logic's chord trigger to create intervals. You can create certain intervals with Logic's plugin chord trigger. It's a MIDI effects plugin. From the drop-down menu that reads Factory Default, choose Single Intervals, then choose an interval from the 12 intervals listed in the quality number form. Click on a note in the trigger keys to hear the ascending interval selected. First, we open up the chord trigger. Then from factory default, we choose single intervals, and in this case, I'm going to choose perfect fifth, and then I play. With Finale's transposition tool, you can also create intervals. To create a harmonic interval, first put a note in a measure. Then select the measure and open the transposition tool. Make sure Preserve Original Notes is checked to retain the starting note. Then select Direction, Method. Diatonically is the same as natural. The interval, and add octaves to create compound intervals. Then press OK, and you will create an interval. So first we're going to select the measure and copy it into a new measure. Then from Utilities, we're going to choose Transpose, making sure that Preserve Original Notes is selected. And then we're going to create first a major second, and then we'll create a minor second. You can invert intervals with Logic. So to invert an interval up in Logic, we're going to open the MIDI transform, then select the lower note of the harmonic interval. Select transposition from the presets and add 12, and then operate only, and it will create the inversion. If you want to invert an interval down, same process, use the MIDI transform, select the upper note of a harmonic interval, select transposition and sub 12, that is subtract 12, then operate only. So now we have created an interval of a perfect fourth. We select the lower note, then we open the MIDI transform, and we choose the preset of transposition, and we're going to set it to add 12, as in add 12 semitones, then operate only to get the inversion of the perfect fourth, which is a perfect fifth, and then we can Control Z to undo that, and Command Z to undo that, and then we choose the upper note, and we, instead of adding, we subtract 12. Once again, operate only, and we will get the lower inversion, another perfect fifth. You can invert intervals in Finale. You can first select a harmonic interval, then from plugins, scoring and arranging, select the canonic utilities. From no inversion, select either chord inversion up or chord inversion down. From the mirror inversion options, select the upper pitch as a pivot for an upwards inversion, or the lower pitch as a pivot for the downwards inversion. You will have to know the pitch and octave position of the pivot note. Then you press apply. We're starting with a major third of middle C and E4. We take the measure and we copy it, and then from plugins we choose scoring and arranging, and then canonic utilities, and we're going to choose chord inversion up, and from the mirror inversion options we make sure that the pivot note is set at E4. We say OK, and from a major third then we get a minor sixth as the inversion.